Hi, this is a continuation of review of type 10. This is problem number 2 in the packet that I do have. And so we want to look at what happens with this one. So they give us a table of values. Those values tend to turn out to be different order derivatives, one of them at 0 and one of them at 1 evaluated out. And so they want us to write the Taylor polynomial. So a good thing is to write out the general form of the Taylor polynomial. That will probably make things a little bit easier. So the first question asks, what is the fourth order or fourth degree Taylor approximation for f of x centered around 0? So I'm going to be centered around 0, so I'm going to use that. Try this and come back and see how we did it using this general form that we do have over here, but it is around 0. So since this is centered around 0, the c value from up here is just 0, so I just get those terms with nothing else grouped with the x, and that is the fourth degree Taylor approximation for f of x centered around x equal to 0. Now if they gave us a function instead of all these different values, then you would have to go take the different derivatives, plug in 0, and then find out what those were, and then plug them in just as we just did. Part B says find the estimate. All you do is wherever you see x, plug in 0.2. Now, I don't think that they would take something that had this many pieces and have you plug in 0.2 to it. That might be third order, but I just did fourth order as a practice. Then part C, find the third degree Taylor polynomial approximation for f of x centered around x equal to 1. Notice that now it's third degree. If you write fourth degree, you're going to get it wrong, so don't do that. Write third degree Taylor approximation. So there we have that, okay? Check that with your work and see if that's right. Oh, go back and always check to see if you did your factorials, because that's the most common thing that people forget. Sure enough, I forgot them, so I'm going to go ahead and put them in. I'm not going to simplify at all, because I don't have to. But that would be my polynomial. I can put equal sign here because it is the third degree polynomial. That is an approximation for the Taylor series. You put approximately equal if you're saying g of x is equal to this, okay? So just understand that if you want to be safe, always put approximately equal, not just equal. Then it says estimate f of 1.2. That would be for this polynomial. Since 1.2 is closer to 1, we're going to plug it in here. So this would be P3 of 1.2 and leave it. Okay, so make sure that you just leave all these problems as such and get on to the calculus portion of this as much as you can. Okay, part E, h of x is equal to x minus 1 times f of x, and that forms a Taylor series around x equal to 1. Find h triple prime of 1. Well, you can go through and multiply every term by this and then take all the successive derivatives that you want. However, there is a shortcut, so let's see if we can use the shortcut and see what happens. So I'm just going to write out h of x with the x minus 1's in there. So my first term is and this is centered around 1, so it's going to be my 7. So I'm looking right here. 7 times x minus 1. So h of x is approximately this third degree polynomial. And so when I want to find h triple prime of 1, well, that deals with my coefficient that's out in front here. And so the coefficient and the 2 factorial. Okay, so we know that h triple prime, let me write this out, h triple prime of 1 divided by 3 factorial is going to be now equal to whatever this coefficient is right here. Well, this coefficient turns out to be 1/2. And it's so I'm negative. Going to end up with h triple prime of 1 equaling 6 when I just multiply both sides by the 3 factorial. Oh, it's 6 divided by 2. That equals 3. Okay? Negative 3. So h triple prime of 1 is equal to 3. Now, you could go ahead and take the derivative of this thing 3 times, but notice that this term will drop out, this term will drop out, and you just take the 3 out in front here, and then the 2 out in front, and then the 1 out in front kind of for your last one when you get constant. But you just can just use this formula and it goes straight away like that. Okay? And I get that from way up here. That's where I get that from, and then the 1/2 I get from right there. Okay? They're equivalent. Now here, there's 6 problems, and you have to determine the convergence or divergence and then explain why. So there's essentially 3 tests that we do have on this exam. One is the harmonic P-series, and then another one is the alternating series test, and the last one is the ratio test. Try these. Pause this. I'm just going to write out the answers and see where we go from there. You could talk about absolute convergence or conditional convergence as well. However, that's not going to be on this year's test, but I might throw that in too, so you might want to think about that as well. So pause and try these. So 3 is convergence by the alternating series test. Make sure you put the reason in there. 4, it's not one of the tests, but it diverges because of the nth term tests. Terms do not go to 0. 5, converges by the P-series test. P is equal to 3/2, which is greater than 1, so we got convergence. 6, if you simplify that, you get n to the negative 2/3. But remember, the P-series test is 1 over n to the P, so P would be 2/3. So I'm looking right here. P is equal to 2/3, which would be less than 1, diverges by the P-series test. Then 7, we have all this gunk, and when we have all this gunk, factorials, exponentials, then we probably use the ratio test. Take the next term, and then divide it by the now term, which means you multiply by the reciprocal. And when you simplify that, this just becomes a 3 on the bottom, so it's 1/3 and n plus 1 over, I lost my n plus 1 there when I cancel this with this. Yes, I get n plus 1, so the limit as n goes to infinity of that is infinity, so that's greater than 1, so this is going to be divergent by the ratio test, which makes sense, because if you just had to brain this, the factorial grows faster than the exponential, so that bears that out. It's not a multiple choice test, so you would have to show all this in order to verify that. Ratio test on this one, next term, and multiply by the reciprocal of the now term. And let's me make sure that I got this right. So n squared over n plus 1 quantity squared, as n goes to infinity, that's going to become a 1. And then I'm just going to be left with a 3 and a 4. So it's 3/4 overall, which is less than 1, convergence by the ratio test. Okay, so we have jumped to the last page because the other pages are some AP problems that you can try. But for number 12, I gave you a geometric series. And so it's written a little bit funnier than what we normally see, so I have a sub n and x minus 1 to the n minus 1. Then we have all these values, and so they went ahead and found all those values for us, and that works with the a sub n. They do tell us it's geometric, so that means when I go from successive term to successive term, I'm going to be multiplying by the same thing over and over again. Look at for the terms outside, it looks like I'm going to be multiplying by 1/2 every time. Okay, and then I have the x minus 1 every time as well. That's from here. Okay, so the a sub n is the geometric series, which is 3 times the ratio of 1/2 raised to the n minus 1. So go ahead and try this and see how they go. Pause, and then come back to me and see what we're doing. So first of all, identify your first term and identify your ratio. So I have this right here. And for part A, it says plug in 4/3. 4x, so I'm going to plug it in here, I get a new ratio. So A1 is equal to 3, and then R is equal to 1/2 times 4/3 minus 1. And I messed up here because this should be a negative, and I changed it up there too. So there's my series, and then I just need to do the general term. Well, the general term is going to be 3. It's geometric, right? So it's going to be 3, and then my ratio is negative 1/6 to the n minus 1. I actually don't like to do this. Oh, I'm making a mess here. Oh, that didn't work. So I'm going to go plus. There you go. So now this looked like a scary, scary problem at the beginning. However, if you just read it and figure out, okay, geometric series, I need the first term, I need the ratio. Oh, x equal to 4/3. Okay, okay, that isn't so bad. Get in there and try something, even though it looks kind of funky. It shouldn't be too bad, but get in there and write it. So part B now says find the sum when x is equal to 4/3. Well, we already found out what that ratio is. So the sum of an infinite geometric is this, and so I'm going to get my 3 over my 1 minus r, which would be plus 1, 6, which is 7/6, and so that would give me my 18/7 right there. Okay, so that's my sum. Okay, I might not have gotten A and B, but then here it says write out the first 4 terms of the derivative of this series that I gave you at the beginning. Oh, I can do that. I'm just going to take the derivative term by term. And so they say find the first 4. So the first one, the 3 goes away, so it's -3/2. And then I'm going to get my 3/4, but I've got to multiply by 2. So then it's going to be plus 3/2 x minus 1. We still have the x in there because it's from the beginning. And then minus 3/8. So if I divide that, I'm going to get minus 1/8. I did that the wrong way. So it's 9/8, put in the denominator by accident. And then this last term, well, they don't help me here. However, they gave me this term here. So I should be able to go ahead and write what that one is. I know it's going to be positive. And then if I plug in, well, this one, to get the n minus 1 to get a 2, I needed the third term. So I'm going to plug in 4 for this term here. So if I do that, I'm going to get a positive, and then that would be a 12. So I'm plugging in right here. And then 2 to the 4th would be a 16. I'm not even going to simplify that. X minus 1, n minus 1 would be 3. So there's my first 4 terms, namely my B1, B2, B3, B4. Okay? Then the last piece says, let's use the ratio test to try to figure this, to see what's the interval of convergence. Oh, it's b sub n over n squared. So it's going to be this series and divided by n squared. Well, here's my general term, so I should be able to put all that together. So the limit of my next term, ooh, that's going to be a little gunky, but it's okay. And with the absolute value, the -1 will kind of go away. So there's my next term, and don't forget, you do have this additional thing from the b. So it's that n squared right there becomes that right there. Then I'm going to divide by the now term, which means multiply by the reciprocal of the now term. And I left out the -1 to the end because that's going to cancel out the absolute values. Then I'm going to try to cancel some of this stuff. Well, as n goes to infinity, this thing will behave much like this thing. So that will give us a 1. Here's a 2 to the n and 2 to the n minus n plus 1, so this would be a 1/2. And then the n squared and the n plus 1 squared, those will behave in a similar fashion. So all I'm going to be left with is, and then I get one of those x minus 1s at the end. Okay, so then this thing has to be between -1 and 1 in order for us to converge. So if I sort that out, that'd be -2 x minus 1. And this would be a 2. Add 1 to all sides, so this would be -1 x, and this would be a 3. Now remember, you have to check endpoints. And I'm not going to get into this too much, but if I take -1, and I plug it back into this right here, and that's for x. So I'm going to plug it in right there. I'm going to get -2 for my base. Let's see what happens when we do that. So when I look at this, I'm plugging in -1. This thing's always going to be negative. Oh, so it's always going to be the same sign. So if I simplify this a little bit, notice that the 2 to the n minus 1, and that it gives me a 2 in the denominator. And then I get, we said this is negative all the time, so negative out here. And then I get 3n. And what did I forget? I forgot the n squared. So I get this over n squared, which is equal to -3/2. I put it in the wrong spot again. And this is going to diverge because it is a harmonic. So there's an example of our harmonic and a divergence for that. So we're not going to include the -1. If I do the same thing with 3, I kind of ran out of room, but I think you can see that instead of having the -2 right here, you're going to have a +2. And so when I plug in 3 and I get a +2, I should be showing all this, by the way, I'm going to get an alternating sequence with this 1 over n. Well, our alternating harmonic is okay, and as we showed before, the terms go to 0, and each successive term is less than the previous term, so therefore it does converge by the alternating series test. And so if we write this out in the end, this is going to be -1 not included and 3 included. There's my interval of convergence. I should have shown that all. And there I did show it for x equal to 3, converges by the alternating series test. Okay, then the last question. Some people want to get in there and do a lot of different order derivatives. When do you do that and when do you not? Well, if you can find the Taylor series, the general form of the Taylor series, and match it up with the terms that you do have, you shouldn't have to do a bunch of derivatives. However, if you don't have all the terms for the Taylor series and they didn't give you the terms, then you're going to have to go find them, and so you're going to have to find all those different order derivatives to find all those coefficients. Don't forget your factorials. That's the big one. Please don't forget those. So that's when you're writing the general forms of those. Okay, I hope this all helped. It cleaned things up for you a little bit. At least it gave you some examples of the geometric alternating series test, ratio test, and whatever else we did have, the Taylor polynomials. Okay, thank you. Good luck on your AP exams.